Hey guys, this is Mainak and today we'll see how to apply the moment of inertia clause to a building. So if you look at the earthquake code or the Indian earthquake code IS 1893 part 1 2016, by the way this clause is same as in the ACI code as well. So the moment of inertia for a structure when you are doing dynamic analysis shall be taken 70% of gross of columns for columns and 35% for gross of beams. So how to, whenever you go for vetting, structural vetting, this question will be asked whether you consider this criteria in your design or not. So we'll see how to consider this criteria, and we will also see what difference does it make to the analysis of the structure. So this is a building which has been designed. If you double click on the building, obviously complete design will be seen. So just note down the AST, let's say for this left section, side sections, let's note down the first two digits. 1300 is this one, and then we have AST required 1900, and then 2700 and 2000. So in this we haven't considered the correct beam or the moment of inertia which has been given in the IS code. By default instead it is taken as 1. So how we can do this? Go to specification, and in this specifications you can just click on here in the beam, or you can also click on here, and you can click on crack property. Okay, by the way I'm using STAAD Connect edition, so if you are using earlier versions you can do using this also. Okay, so you can see this is the reduction for cross section area. No need to change this, but this Rx, Ry and Rz you need to change. So first of all let's define for the columns. So let's define 70% for the columns. Okay, 0.7 and 0.7. click on add, and again we'll add here crack property. This property reduction factors here we'll consider 0.35, 0.35 and also 0.35, and this property. Now we'll add the first property to the columns. If you are adding groups, then you can select your groups, otherwise I'll just select parallel to Y for all the columns and assign, and yes, and then I'll assign this to the beams. So select this and parallel to X and parallel to Z for all the beams, and then I'll click on assign, and yes. So these two properties have been assigned. Now you will change, do the run analysis once again to see the changes in the structure, and let's see what is the changes in the structure and the reinforcement also. Okay, so let's click on this, let's click on concrete design, and let's see. So you can see the AST required 1600, 2100, 3000 and then 1900. So in most cases the reinforcement has increased from the earlier cases. You can see. Okay, let's click on the beams here. You can see 10 10 5 10. Okay, here also you can see these results. So basically what it does, it considers less percentage of the section. So for beams it considers 35% of the section. Like if we when the earthquake will occur, clustering hinges will occur, 35% of the area will remain. So like this they're considering. And for the columns, since it's mainly compression, some cracks will disappear due to compression itself, will not form due to compression itself. So that's why 70% more area is considered for columns than beams. So beams are very important in the case of earthquake. So you will find this clause which is same almost for all the country's earthquake codes, and this is how you can apply. Keep learning. Bye bye.